This video is a quick introduction to ratios. Ratios are nothing new. It's not something that you have not seen before. It's just we're given a name to it now. So let's go ahead and take a look at what a ratio is. We're going to start by defining what a ratio is. In general, a ratio is an expression that shows the relationship between two values. It tells us how much of one thing is there as compared to another. If we were in class right now, most likely I would use the ratio of boys to girls that are sitting here in this classroom right now. I'm the only one here, so I can't really do a ratio like that. What I do have, though, is Flair pens on my left and Sharpie markers on the right. I could make a ratio of how many Flair pens I have to the number of Sharpie pens that I have. So we can count here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 Flair pens. And I've only got 1, 2, 3, 4, 5 Sharpies. So here are the three ways that we could write our ratio. We could write it as 11 Flair pens to 5 Sharpies, which is represented there at the very top. We could write 11:5 is another way to represent a ratio. And the last way in the bottom right corner down there, 11/5. We can make it look like a fraction. It's another way of writing a ratio. Of course, we could add labels to any of these. So I could write 11 Flair pens, 5 Sharpies, or 11 Flair pens over 5 Sharpies in the bottom right corner. If you're somebody who wants to take this down in their notebook, I would. This is the three ways that I was referring to when we're writing ratios. A to B, using the word to, A:B, or A over B with fraction notation. The A and the B here are just standalone variables. So in this case, A would have been like the Flair pens, and B would be like the Sharpies. We're going to look at one more example here, and while we're doing that, I'm going to explain what a part-part ratio is. We've already taken a look at one with the Flair pens and Sharpies, but let's do it with some dogs and some cats. So in this example, we can take a look at the number of dogs compared to the number of cats. What's the ratio? Well, we can see that there are along the top 4 cats, and on the bottom there are 3 dogs. So if we were to write that as a ratio, giving part to part, it would be we have 4 cats to 3 dogs. So once again, there are the 3 ways that you could record this ratio. Now let's talk about what if we were comparing part to whole, meaning that we are looking at one individual part, so either the cats or the dogs, compared to the total number of animals that are in this picture. We know that there are 4 cats and 3 dogs. That's a total of 7 animals. So one part to whole ratio that we could write here is that we have, so here are the 3 ways that you could record that part to whole ratio of cats to total number of animals. We could do the same thing with the dogs, and it would look exactly like this. One more thing that I want to talk about with ratios before this video is over is scaling up and scaling down ratios. In order to do this, we are going to be thinking about a bike, and we're going to be using the ratio of 1 bike to 2 tires. Bicycle, the bi means 2, and we're talking about a 2-wheeled bike. So 1 bike has 2 wheels. So here it is. This is what we talked about in the last clip. 1 bike to 2 wheels, 1 to 2, 1 bike over 2 wheels. Doesn't matter how you write it. We're going to talk about scaling up this ratio. Now just humor me for a second. If I have 2 bikes, how many wheels do I have? Did you say 4 in your head or out loud? You're right, there are 4. So let's go ahead and record that. I created a ratio table here. We're not going to cover this in this video, but we'll learn about this in the future. So 1 bike is 2 wheels, 2 bikes is 4 wheels. Okay, something that I want to notice here is that when we're scaling up, look at this. We are multiplying by 2. We are multiplying by 2. 2 times 1 is 2. 2 times 2 is 4. Imagine if we had 3 bikes. If we had 3 bikes, we would have 6 wheels because each bike has 2 wheels. From my original ratio of 1 to 2, I want to show you this. We could multiply by 3. By 3. And by multiplying by 3 to the top and the bottom, we are scaling up. Now I have filled in one more ratio here, 8 to 16. It is equivalent to this 1 to 2 ratio. Okay, how do we know this? Well, I'm going to show you that if we scaled this ratio down, we would get back to this 1 to 2 ratio. So let's look at 8 bikes is 16 wheels, or 8 bikes to 16 wheels. We know that anything divided by itself is going to be 1. So in order to get 8 back to 1, I'm going to divide by 8. And we're going to do that in our next box here. So we are actually going to divide by 8. And if we do that to the top, or we do that to the bikes, we have to do that to the number of wheels as well. It's what we did over here when we were scaling up. We multiplied our bikes by 2. We multiplied the number of wheels by 2. It keeps the ratio equivalent when we are scaling up or scaling down. So we're going to take 16, and we are going to divide that by 8 as well. And we would get 1 bike is equal to 16 divided by 8 is 2. 1 to 2, which is what our original ratio was. So here we are scaling up, and we can divide in order to scale our ratio down or to simplify it. And that's your quick introduction to ratios.